Hello and welcome to physics unit 3 area of study 3. No, 2. This is area of study 2. Am I recording? um Recording on this. I'm recording. How do I? Hello. Hello. I'm gonna put it here. All right, let's get started. A magnet approaches a coil with 6 turns as shown in the diagram below. During time interval, magnetic flux 0.05 Weber and the average induced. So this is the change in Weber, change in flux, and the average induced EMF is that. Let's get scientific, actually graphics cap, not scientific. There's a difference. So the formula is the 0.05 times that by 6. And we get that. We divide that by 1.2. I got 0.25 seconds. Is that correct? That is correct. Too easy. All right. The diagram below shows a simple electrical generator consisting of a rotating wire loop and a magnetic field connected to an external circuit. Split ring, the direction rotation is the arrow, so it's clockwise. It's a split ring. Which one of the following best describes the function of the split ring? Comes in next October. It delivers a DC current to the light globe. It delivers an AC. I don't think it's AC. It ensures the force on the side of the loop nearest the North Pole is always up. It ensures the force on the side of the loop. Wait. It ensures the force on the side of the loop nearest North Pole. It ensures the force on the side of the on the side of the loop nearest the North Pole is always up. It ensures the force on the side of the loop nearest the North Pole is always down. But it says generator. Wait, what? I'm getting confused. I don't think it's AC. Could be DC. Delivers a DC current to the light globe. Okay, it is that one, but that was kind of a wild guess. AC generated in the rotating coil reverses direction every half cycle. The splitter commentator reverses this. Okay, you could just say the splitter and commentator does not do it. It's just a DC. All right. Next, two concentric loops of conducting uh two concentric loops of conducting wire are placed on a flat horizontal surface. The outer loop contains an open switch and a battery cell. The inner loop consists of a single closed loop of wire. The diagram below shows the arrangement of the two loops as viewed from above, which one of them best describes the induced current in the inner loop when the switch is closed and outer loop is open. Okay, so the longer side, see here, the longer side is positive, the shorter side is negative. So can we use conventional current in physics? So positive to negative. Positive is going anti-clockwise, the current that way from this point of view, from that way. It's going into the page. No, it's going out of the page. Dots. And this wants to oppose it out of the page. So that's going. Has to be way where it's going. If this is anti-clockwise, this has to be clockwise. So I'm guessing this is clockwise. What are we about momentary? Is it always closed? Yeah, it says when it's always closed. So what did I say? This is anti-clockwise. Can I add the page? Can I add the page? Want to reverse it and put it into the page? So it's going clockwise. What? Momentary. What is it? Momentary clockwise. What's momentary? Like what? As the current and outer loop builds up from zero, there will be an increase in magnetic flux. Does it say the current is increasing? What it was fixed? I don't get it. As the current in the outer loop builds up, how does it, when it builds up from zero, there will be an increase in magnetic flux. Yeah, there is an increase in magnetic flux, yeah, from zero to a fixed value, like 2 amps, for example. It will flux page. It'll be out of the page in the inner loop. Yeah, this will induce a clockwise current. Yeah, that's what I was getting to. This will induce a clockwise current in the inner loop, causing an opposing flux into the page. Yeah, to oppose the flux into the page. But what's the difference between momentary and steady? I know the words definitions, but why would it be momentary and steady? Hmm. This is 2022 NHT. Question 6. So it builds up. No, I don't really get it, but I don't know. It is what it is. That's momentary. All right, I'll ask the teacher about that question. Why is it steady instead of momentary? I don't know. All right. Wait, question 20 out of 20. Wait, is that all the questions? No way, bro. I finished that in like an hour. Damn. All right, last one, and we'll call it a day. Yeah, because it's nearly 11:30, man. I'm tired. All right. A simple electricity generator is shown in diagram below. When the coil is rotated, the output voltage across the slip rings is measured. So slip rings, AC, it could have a negative value, is correct. The graph shows how output voltage varies with time. Yep. The frequency of rotation of the generator is now double. So when the frequency, how fast it moves in one rotation per second is now doubled. So it's really fast now. It's twice as fast. Which one of the following graphs best represents the output voltage measured across the slip rings? So when it's going twice as fast, right? Twice as fast, the the time for it to complete a full cycle will decrease because it's going really fast. It will decrease, so it will be the domain will slightly be like lower, and it will be a higher, yeah, higher amplitude. That looks like the exact same graph. I don't think that's it. This looks like this does not look right, I believe. It's got to be more compressed. Oh, maybe no, this does look right. It does look right because it's been doing more cycles in 0.1 second. Okay, it's taking 0.1 second. And a higher amplitude as well. So I'm guessing it's this one. Yeah, that's the correct answer, man. Oh yeah. Oh yeah, got it right, got it correct. Oh yeah. Doubling the rotation rate will double the peak voltage and half the rotation period. Hmm. Well, that was surprising. That's only 20 questions. Wow, generation principles. That is interesting. So that's generation principles. So in this area study, it revolves around the scope of generation principles and transformers and transmission. We've been looking at transformers today. What's this? I didn't even answer this question. There's 25 questions in this one. The key principle involved in the operation of an electrical transformer is electromagnetic induction and law. Standard knowledge. Uh, Electromagnetic induction induces an EMF. Yeah, RMS. Yeah, there was some questions, equations about this. So yeah, ratio. All right. Yeah, I think that's it for today. Yeah. All right. Anyways, I'd like to say thank you to you guys for watching this beautiful live stream of me doing some physics questions and answering them, and you listening in, hoping you understand them. And yeah, I just want to say that. And I'm trying to end the broadcast. Oh wait, I think no. Stop recording. Wait, stop recording. Pause recording. Or stop recording. All right, anyways, thank you guys very much for watching, and I'll see you guys later. See ya. Yeah. All right. Bye bye.